Hey everyone, today we're going to be troubleshooting the ignition system on this Honda EU2000i inverter generator. This is part of a multi-video series dealing with no start and hard start conditions of this generator. You can click a link in the top right, will take you to the video listing for this. The ignition system in this generator did not function as it had arrived and required troubleshooting to resolve the issue. We'll go through all the steps that brought this problem to resolution. Let's get started. Many of these basic tests only require the access panel be removed, however. For the purpose of this video, I'm going to remove this side molding, the gas tank over here, as well as this air box. It may not be entirely necessary to remove all these pieces to troubleshoot. This makes it easier to record the video. Also, I'll be going through a detailed procedure of this breakdown at the end of the video. The area around the spark plug was already blown out with air. I'll remove the spark plug with a spark plug wrench. The plug itself appears to be in good condition. If not, the plug would have to be replaced for testing. I had one of these spark tools on standby if the plug was no good. We'll be testing with the OEM Honda plug. Ensuring there's a good connection, I'll lean it up against the block where I could see the electrode. I don't know how long the engine's been sitting, so I want to hit it with some fogging oil, so I'm going to spray it right down into combustion chamber and just give it a couple of turns. Spray it again when the piston is in the all the way down position. It's most effective. Naturally, I want to check the oil level and quality. It seems to be decent. I'll give it just a couple more pulls with the fogging oil. And now that it's safe to repetitiously pull the engine, I could clearly see that there is no spark on the spark plug. But we do have compression as I put my thumb over the hole for the spark plug. Everybody should have a copy of the shop manual for this generator, which includes, amongst other things, a troubleshooting flowchart for the ignition system. We're going to start by disconnecting this green and black cable coming off the switch on the side panel. This is that big on and off switch on the bottom right. Not only does this cut the fuel, but it also grounds the ignition, so it removes a variable from our problem. This switch, however, was not the cause of our trouble. Now I disconnect the 6-wire harness. Setting my meter to ohms, I'm going to measure the green and the yellow connection. I should expect to see infinite or open. This correctly reads that there's enough oil in the system. If it's reading 0 or closed, check the oil level. If it's not low, you may have an oil sensor issue. The oil sensor is in the middle of the engine, significant amount of work to replace, and that would be for a separate video. If the oil's really nasty, you could try draining and refreshing with fresh oil to unstick the sensor. Again, on ohms, we're going to read green to blue. We should see between 300 and 360 ohms. If you do not, click on the chapter for the disassembly of this unit to take you to the ignition pulse generator to directly test or replace this unit. If you pass that last test, you could switch over to millivolts, and we're going to be pulling the handle several times to check for voltage. It says between 3 or 4 millivolts, but we see about 30 to 40 millivolts. If you don't see a voltage, again, you could click on the chapter to take you to that section on the testing of the pulse generator. Now I'm going to get an exact value of the resistance in my leads, which I find is about 1 to 1.1 ohms of resistance. As I connect up the meter, I give it another second to let everything settle down. And when it does, we end up with 1.4, and I subtract 1.1, so I end up with about 0.2, 0.3, so that's good. High resistance or an open would mean replacing the exciter winding most likely. I'm going to switch the meter over to AC volts now and find a more sturdy way to connect my leads. In the same connections as before, I'm going to pull several times to see if I can get around 4 or 5 volts. This is not a perfect science to some voltage drop in these cable connections, so you can see me getting 3 or 4, that's just fine. No voltage would point towards the excited coil. Now I'm disconnecting this bullet connector, checking my resistance of the cables one more time to measure the primary and secondary windings of our ignition coil. And this first side we're going to test here, and we're seeing 1.5 minus my value is about 0.7, so we're good. And the other side we're checking, and we're seeing 17,000, which is also good. If this were bad, the ignition coil would need to be replaced. This takes us to the ignition control module. All you can really do is check the harness, and we're going to remove the 4 screws that hold on the front panel. The module is a square box located right here with the wire harness going into it. And we'll check that harness now. This one was actually not fully seated, as we see. I'm going to put some deoxit on a toothpick so I could scrape the pins gently to make sure I remove any dirt. especially on the exposed pin, so we're up a bit. Respray everything one more time, then blow it out with canned air. We'll plug it back in and see what we got. If this doesn't work, each of these wires is going to need to be ohmed out, and if those are all good, this ignition module is going to need to be replaced. Before reconnecting all these connectors, I'm going to hit them with deoxit on both sides. We'll keep the ignition cutoff switch disconnected. And as we pull the pull start now with the spark plug connected, we see that we do in fact have spark. So it was the cable that was not all the way connected or had a bad connection that was causing the issue. So now we're going to re-plug in our ignition cutoff, make sure it's set to on. Try it one more time. And we see that we do continue to have spark, so this is repaired. What if it's not repaired and we got to cover some of those components that were inside the engine? 4 Phillips screws holding the faceplate. I remove them now. Pulling the faceplate forward, I put the 4 Phillips screws back in so I don't lose them. There are 2 separate harnesses here. One's on this side, going to these parts, and there's another one with a ground here. Pressing up on this tab allows this cable tie to be pulled through. Disconnect the cable from the ignition control module. Connectors off the echo switch. Connectors off the parallel operation. The Phillips screw on the outlet is loosened a couple of turns. The connection is pulled straight out. Connections are then pulled off the AC breaker. I've loosened the Phillips screw on the outlet for the neutral wire and pulled it out. The ground for the panel was completely stuck, so I sprayed it with some thread loosener. I'll come back to it. These 2 connections are the DC receptacle. I push the button in the middle to release both of them. Take out one and then the other. At this point, I'm able to pull that ground screw out from the bottom. And with that, the front panel is disconnected. The condition of the front panel should be checked. If you had to swap out your ignition control module, now would be the time to do it. We see that there's some rust towards the bottom. Put the screw in for now. We'll deal with it later. There are 2 Phillips screws on the top side of the cover. They will be removed first. This is followed by the 2 Phillips screws on the bottom front of the cover. They're removed next. Using an 8mm, we'll loosen these screws inside. There are 3 of them. This one functions as a ground post. With the 3 screws removed, we could carefully guide the wires through their respective holes as we pull this front cover off. Four Phillips screws hold on the rear of the unit. We'll remove those screws now. This rear cover should pop right off. A Phillips screw holds in the pull starter. This plastic trim snaps down and outward and removed from the unit. Same thing on the other side. 2 long bolts are found under the plastic trim. They're unscrewed now and removed from the unit. This is followed by 2 screws that are found on both sides of the handle. Mine are hex because I've replaced them after some repairs. Lifting up the gas cap shield to release the handle, everything is carefully checked and removed. The hoses, the pull start, releasing this plastic from the generator. On the other side, the gas cap rubber is also lifted, releasing this plastic. There's a lot less to get in the way of this one, so it's a lot easier to remove. And then it's just lifted sideways and outward. The 3 screws are placed right back in the inverter. These 2 Phillips screws would then be loosened, but they've already cracked off this generator. I disconnect the fuel line, go into the pump, and remove all the gas from the tank. The tank is then removed from the unit. The 2 connections are then disconnected from the inverter. The harness is pulled out of the holder, and the inverter is then removed from the unit. I take a minute to check the inverter for any damage, heat, explosions, burning, bubbled up capacitors, stuff like that. The other side actually has a screw, so I'll attempt to remove it. And it is frozen in there. So I'm going to spray this screw, and then I'm going to come back to it. 8mm socket takes off the 2 nuts that holds on the air filter and the carburetor, so I loosen those. Disconnect the crank vent and pull off the whole air filter assembly. Engine vacuum is disconnected from the fuel pump. Fuel pump out is disconnected from the carb. Finally, the ignition switch is disconnected, which allows this bracket to be removed. The gasket is removed, followed by the carburetor, followed by the inner gasket. This screw that had been soaking is now able to be loosened, and with that, this bracket is able to be lifted off. I put the screw back in so I don't lose it. I do the same thing on the other side, even though the bracket's broken, because I'm going to repair the bracket and I need the screw working. I use a large screwdriver to slide these mounting lugs through the bottom plate and push them out. There's the front one. I do the same thing in the back. Now the engine can be lifted off the bottom plate and set to the side. Opening this rubber cap exposes the third 10mm bolt that will be removed to remove the pull start assembly. Take the assembly off and put it to the side. The 3 screws are then reinstalled into the unit. The rectifier cable is disconnected, as well as the connection to the ignition coil. 8mm will also remove these 2 grounds found on the lower left side of the engine. Just as before, the screws are put right back in. The coil cable is disconnected from the spark plug, and these 3 8mm bolts are then removed to remove the fan housing. The fan housing is pulled off and stored in a safe place. If the pulse generator wasn't measuring between 300 and 360 ohms, you can measure it directly from here. Pulling this blue cable off, we take out our ohm meter and go directly off this pin and ground on this screw to take a measurement. If this is out of spec, then this part needs to be replaced, end of story. If it is in spec, you want to go and check this blue wire through the harness from here to the other end to see where the break is. If everything was in spec but you had no voltage, check this raise right here, make sure it's in good condition, there's no obstructions on it and no rust. And if it is in good condition, we're going to rotate it so it's under the sensor right here so we can take a gap measurement. And I'm going to start at 0.2, which is the absolute minimum. And I can see that 0.2 clears on mine. And I'm just going to raise it up here, 0.25. We're just going to see how far we could go with mine. 0.7 is the maximum. So we're at 0.3. 0.33. 0.4. That's where we ended. If it did need adjustment, you could loosen with 8mm this screw up here up top. There's also one here on the bottom. Stick a feeler gauge in and then push this thing into specification and tighten it down. Retest everything after that. Under these 2 bolts of the pull start is the stator cover. Under there is the stator, and if you had no voltage, you would have to replace the stator. All this comes off. I'm not going to pull all that off with a puller just to demonstrate it, but that would be the last thing at that point. Having everything else tested is good. We'll commence with reassembly. There's a detent here for the rubber grommet for the cable harness. There's the grommet right here. That'll go in first. So slide that all the way in till it stops. The fan shroud will then be lowered into position, and the 3 bolts will then be inserted, turned a couple times to align everything. The screws will all be tightened progressively so that the seal gets compressed evenly. And then all 3 of the screws will be tightened down. The engine is now lowered onto the tray, aligning the mounts. The front pin is slid through first, securing that portion of the engine. This is followed by the rear pin. Shaking the engine during install makes it go in easier. The screws for the 2 grounds on the fan shroud are now removed, and these grounds are reinstalled. The cable is reconnected to the rectifier, as well as the barrel connected to the ignition coil. These 3 screws are now removed that hold on the pull starter. The pull start handle points to the left. It is laid into position, aligning the 3 screw holes. The screws are then installed to hold it into position. The slack is removed, and all 3 bolts are then gently tightened down. A quick test shows the mechanical function to be working properly. I'm using new spark plug, so I'm making sure it's measuring 0.7 gap. Installing that into the engine now, screwing it by hand to full seat. And now I'm going to torque it down. Since it's new, there's a washer that compresses, so it's kind of an eerie feeling. You think it's stripping out, but it's actually just a compression. And I pop the cap back on. The cob will be installed at this time, first with the inner gasket, followed by the cob, which slides right on. And then the outer gasket. You'll note these gaskets are all new. Now to the gas tank. There's a rubber holder right here and a detent on the gas tank that sits in it. So we're going to push the gas tank into that rubber holder to seat it. It's only seating on one side for now, but it will hold the gas tank in place. Now the fuel line will be connected from the gas tank to the on-off switch. The metal spring clip will secure the hose. Vacuum line from the engine will then plug into the fuel pump. The output from the fuel pump will plug into the carburetor, and the clip will be secured over the carburetor to hold everything together. I'll remove this screw, which has been stored in the frame, and then I'll carefully negotiate the pull starter handle through first. It's got to come through sideways to get it through. Kind of fidgety. And then the bracket comes through. The screw hole or the bracket will face down. This clip goes upwards. Everything kind of fall into place. And then we'll get the screw screwed in on the bottom. The detent on this side of the gas tank goes into this rubber holder, just pressed right in. These 2 circular brackets up top connect together, just like that. Square fitting right here locks in. You'll note extensive repairs on this one, but the concept is the same. There are 2 screws that go through to lock this into place. Turn this damaged screw into a flathead. And that bracket is in. Finally, the ignition switch cable is connected. I've got brand new primary and secondary filters from the maintenance kit. I've replaced the housing seal too. Filters are generally cleaned and then soaked in motor oil, evenly distributed, and then wrung out. The new filters are installed in the airbox. The airbox is then closed up and tightened down. It'll then be installed onto the carburetor, secured with the 2 nuts, and then snugged down. The crank ventilation is then reconnected to the filter box, in this case repaired, and then reconnected to the filter box. Starting the assembly of the case, the spark plug side cover is placed back on. Lifting up that rubber cover for the gas tank, we get that little piece back in position. The other side of the cover, a little more complicated. Got to pull out some of that pull start and pull it through this hole right here. Still have to line up everything as well as that rubber piece for the gas tank. Get that back in position. Push this bracket through, make sure it's fully seated. These are supposed to be Phillips, but again, I've changed them post-repair. So I've got hex, so I'm going to screw in these top screws first, make sure all the plastics line up as I do that. Followed by these long bolts on the bottom, which go all the way through the plastics, all the way through the mounts, out through to the other side. I'm going to tighten this in now as I hold the plastics together and align them. Here's that second bolt that goes all the way through the case out the other side. I am supporting the other side with my hand and aligning it as I tighten this down. Then I snap on the cover for the spark plug. and install this screw for the pull starter. This holds it to that inside bracket. I'm going to feed both cable bundles through their corresponding holes. This is the one on this left-hand side, and then there's one on the bottom, goes in through the right-hand side like this, as I bring this front cover closer towards the end. Before it's fully situated, I'm going to snap in these moldings. This is the first one. Snap it all the way up to the top, and then the second one, I'm going to snap this one up as well. The upper side screws will be installed in the front cover. I use anti-seize on all of these screws that go into metal so they don't get stuck the next time. But no anti-seize on these 3 bolts, which I'm now installing the third bolt, which is actually the ground lug for this harness. These 2 bottom screws will go in. These get anti-seize. And I've started to put on the connections to the back cover based on all the connections I've recorded when I removed it. These are going through the breaker right here, and this is for connecting another generator. This is for the echo mode. I'm reconnecting that now. This is for the ignition control unit. Clean the ground area back to a shine. I'm going to put that screw back in now. Tighten it down by hand first. Hanging the generator off the end of the bench, I was able to tighten that screw from under. Then we have these 2 DC cables that lock into place. The white one goes to the positive annotation, and the black one goes to the negative annotation towards the outside. This cable tie provides stress relief. It goes around these 2 cables in this bundle and is locked in position and tightened down. Covers pushed back and closed in position with the screw set in by hand, and then tightened down with a screwdriver just snug. That's it. The rear cover presses right on. There are 4 Phillips screws treated with anti-seize that hold in the rear cover. Finally, the service panel is reinstalled, and we just secure it down with a flathead screwdriver. It's fully assembled. We'll test it for correct operation, fill it up with some fresh gasoline, turn on the choke, turn on the ignition. Admittedly, I gave it several pulls to prime the carburetor bowl. Drop the choke, the engine sounds good. And that concludes the ignition troubleshooting and repair on this EU2000i inverter generator. I hope you found this video enjoyable, entertaining, and informative. Hit that like button down below. It helps me out a lot when you do. And hit that subscribe button to get notified about more videos like this when they come out. When another video in this series comes out, a link will be posted in the top right. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?